Hi everyone and welcome to the mole and calculations lessons. We are going to be starting today with lesson 1, which is calculating the gram formula mass. So our learning intention is to learn how to calculate gram formula mass for elements and compounds. Some starter questions then are to recap writing chemical formula. You have lithium fluoride, potassium sulfate and ammonium chloride. Now you will need a data booklet handy. You are going to need to look at page 8 for the complex ions like sulfate and ammonium. Pause the video and give that a wee go and then check your answers once you're finished. So lithium fluoride, both lithium and fluorine have a valency of 1. So when we do symbol valency swap divide, we end up with just LiF. Both have valencies of 1, cancel each other out. Potassium sulfate, this time our potassium has a valency of 1, whereas sulfate has a valency of 2. So when we swap them over, we end up with K2SO4. Ammonium chloride, same situation as number 1. We have a valency of 1 for ammonium, and chlorine's valency is also 1. So we end up with NH4Cl. So today what we're going to go through is how to calculate the gram formula mass. We're going to use the data booklet and practice some examples together, and our success criteria is to be able to calculate gram formula masses for both small and large compounds. So we're going to give you a challenge at the end. What actually is the gram formula mass? So this is a note to go on your jotter if you don't have it already. So in chemistry, we often measure substances with a unit called the mole. So gram formula mass is the same as the mass of 1 mole of a substance. And 1 mole of a substance always contains this giant number, 6 times 10 to the 23 number of atoms. So that means in 1 mole of a substance, for example, 1 mole of carbon is 12 grams. 1 mole of hydrogen is 2 grams. Both of those contain 6 times 10 to the 23 number of atoms. Okay, it just helps us compare the compounds with the same number of atoms. I like to think of it as a dozen. We know that a dozen means 12. So if we were then wanting to compare that with half a dozen or 2 dozen, we would simply half and double the number. We know that half a dozen is 6 eggs and 2 dozen is 24 eggs. So we can do similar things with moles. Rather than working with that giant number of atoms, it's easier for us to say 1 mole of something rather than 6 times 10 to the 23 atoms. So, how do we actually calculate the gram formula mass? We have to use a page in the data booklet, which is page 7. Now, in the third column from the left and the right, you have something called relative atomic mass. Now, that tells you the mass of the atom of an element that you are looking for. So, for example, here we have argon. We have argon here. Let's look over at the third column at relative atomic mass. It weighs 40 grams. So if we were ever looking for an atom of argon, we would simply go to page 7 of the data booklet and find it that way. So let's go through an example together. Calculate the gram formula mass of lithium sulfide. So you have the formula there. If the formula was not there, you can calculate it using the SVSDF method. So here is our formula. What we're going to do is we're going to take each element in turn. So we can see from the formula that there are 2 elements in this compound. We have lithium and sulfur, but we have 3 atoms. We have 2 lithium atoms and 1 sulfur atom. So what we have to do is we have to go and look up the relative atomic mass of lithium, which is 7, and multiply it by 2 because we have 2 lithiums in that compound. We then do exactly the same with sulfur. We go and find out that sulfur's relative atomic mass is 32, times it by 1 because we have 1 sulfur in that compound, and we end up with 32 and 14. When we add those two numbers together, that gives us the mass of the whole compound, and that's what we want, that's what we're looking for. So 46 grams then is the gram formula mass or the mass of 1 mole of lithium sulfide. A second example, we have aluminium oxide here. So exactly the same, we're going to go and look up the relative atomic mass for an aluminium. We have 2 of them in the compound, so it's going to be 27 times 2, which is 54. Oxygen, go and look up page 7, is 16, but we have 3 oxygens in this compound, so we have 16 times 3, which is 48. Add them together and we end up with 102 grams. So the gram formula mass, or mass of 1 mole of aluminium oxide, is 102 grams. Here is a task for you to go away and try. It says pick at least 5 formula masses to calculate, and you are allowed to choose the difficulty. So on the left we have the very straightforward questions, and towards the right and the bottom we have extremely difficult ones. So choose them wisely. I would recommend maybe taking one from column 1, and then if you get on okay, doing a couple from column 2, then move on to 3, and then do 4 lastly once you feel really confident about it. Hemoglobin down the bottom right is going to be quite tricky to calculate, so leave that one till last. I'm going to pause the video. If you pause the video, try these 5 formula masses, and then unpause to see the answers. You can then self-mark your work and check that you're getting on okay. So here are the answers to task 1. Mark your questions. Did you get them all correct? If you did, well done. If not, then you can always rewind and go over the examples again, or you can ask your teacher in class, who will gladly help you. So what we wanted to do then is we wanted to be able to calculate the gram formula masses for small and large compounds. So if you were able to calculate gram formula mass for a few different compounds on that last slide, some being small compounds and some large, then you have definitely achieved the success criteria for this lesson. We always like to check it though with an exit task. So which is the correct gram formula mass for aluminium bromide? We have A, B or C. Again, pause the video, do a quick calculation, and then unpause to reveal the answer. So the answer is C, which is 267 grams. That is the gram formula mass for aluminium bromide. And that is the end of lesson 1. Thank you for watching.